Okay.
You take time, it's 20 hours per day.
Go ahead. There we go. Okay. So, doing this a bit on the fly, so I apologize. So, my safety thing, and I'll go through quickly so that Dr. Collins can talk, because I'm sure we're all here for that, not for this. So mine is actually on safety around large magnetic fields, or what Dr. Alan Constant should have known before getting bit by his. Many of you may know the story where he was attacked by his own rare earth magnets and blood. So, getting to the nitty-gritty, training. There actually is no specific lab-based training for large magnetic fields. There are many associated trainings, such as working with cryogenics, electrical hazards, and so forth, but there is no specific training that you take and then take a 5-question quiz and then you can go work on it. All the training is actually done by staff scientists or researchers that work with that large magnet as needed specifically for your work. So if you need to work with a large magnet, then you need to talk to the researcher who's in charge of said large magnet. But what that means is all safety is kind of on you and your awareness. And I put a picture of a ring on there for a very specific reason. It's my wedding ring. When I was first working with a large magnet, it was about a 1.5 Tesla field, and I was starting to go ready to reach into this magnet and put a sample in there, forgetting that this component right there is made of a Gibeon meteorite, which has a bunch of iron and nickel in it. So, luckily I saved my hand, but it was about a bad day for me because I had a ring attached to a finger, attached to a magnet almost. So, it's something to be aware. That also goes for metallic implants, stimulators, pacemakers. A very small magnetic field is actually used for pacemakers, for resetting and so forth. I think it's like 5 Gauss, it's very small. So getting near field is enough theoretically to actually cause problems with pacemakers. Further, things like tattoos and whatnot can give you problems. So the question is, how bad can it really be? I mean, these are magnetic fields, right? The question is, they can be really bad. These are 2 MRIs, which are actually 1.5 T MRIs. They're obviously large bore magnets, but the principles are effectively the same. This one on top grabbed a gurney that weighed a few hundred pounds and just sucked it on in. And the one on the bottom is somewhat amusing, but it's actually a terrible accident. 2 technicians were actually trapped in the magnet by an oxygen cylinder for 4 hours before they could quench the magnet and get them out. So it can be really bad. Further, like there was another guy who had a knife on his belt. Many people have pocket knives and things like that, and they're just unaware of them. Sucked it right off his belt and actually stabbed him in the head and did some damage. There's a 6-year-old boy that was killed by an oxygen tank. Dr. Alan Constant got bit by his own magnets. Another oddity actually you might consider is the human body is actually a conductor, which means induction. And so you can actually have problems with burns if you're in time-varying fields. Large fields can be large varying magnetic fields, where they can actually aggravate dark ink and things like that in tattoos. MRIs have problems with this specifically. And I'm unfortunately one of those people that have to be very careful about the field strength because they'll actually heat up and cause burns. It's kind of like a bad sunburn. So just things to be aware of. But how does that compare to what we do here? So 1.5 to 2 Tesla DC field electric magnets, and they're not uncommon in research. I use one not every week, but pretty close to it. VSMs and MRs can get much higher. They're usually much more contained and shielded, but be aware. You might consider the National High Magnetic Field, which I had to plug there because it's super cool. They have a 45 T sustained field magnet there, and you can see the links that they go to keep people out and away. The big thing is, usually there's some shielding, but flux leakage is a real thing. On my magnet that I work with, I actually had my cell phone stick to the side of it without being aware that it was in my pocket, and it was just where the big chunk of iron came together and had an interface, and there was enough leakage to stick myself to it. So just be aware. In summary, if you aren't sure, ask. By the time a 2 Tesla electromagnet is grabbed onto you, it is most likely too late to do something about it. Your arm is in there, getting help is hard. If you have any body modifications, implants and pacemakers, etc., magnets may or may not be for you. Be aware, this is much more common with the youth where we have piercings and things like that. A lot of times it's advertised as stainless steel, but that doesn't tell you if it's austenitic or ferritic. The cheap stuff actually can be ferritic, so just be aware. Old tattoos, like I mentioned. Cell phones, keys, wallets, you can see this guy's wrench just sucked to the side of the magnet. Look for the tape on the floor. Many of the high field magnets have tape. It can be a variable distance. This is a 5 Gauss example, which, as it says, it's not quite enough to kill you, but it can take out your credit cards, things like that. So just be aware. Remember, by the time you feel a magnetic field, it's likely too late to do something about it if you're in a bad situation. So just keep your wits around you and so forth. Dr. Collins. I flew through that possibly fast enough. So let's save time for questions and so forth.
Okay, thanks.
Sorry.
I have a quick question. Go ahead. No, I have a quick comment. I know you were trying to be humorous and self-effacing, but I want you to tell you that this, what you just did here, is extraordinarily important. And Dr. Collins is important too, but I want everybody every week to really pay attention to this. People get hurt every day. And that was very good, and thank you very much.
Thanks, Mike.